This is a Math 2 Honors Unit 7B review, and we're going to start with number 1 here, talking about angles and standard position. Part A says find two angles, one positive and one negative, that are coterminal with 150 degrees. Coterminal references, so if we have our x and y axes, 150 degrees will be pointed in the second quadrant. Remember, we have 0 degrees pointed east, 90 degrees pointed north, and 180 degrees pointed west. So 150 degrees is between the 90 and the 180. In quadrant 2. Now if I circled around, went full 360 plus another 150, I would end up in the same location, pointing in exactly the same direction. And because of that, the terminal sides would coincide, and that's why we call them coterminal. So the way to do this is you take your 150 degrees, add 360 to it, which is as if I started at 150 and just went a full circle around and ended at the same location. I would get 510 degrees. And if I took 150 degrees and subtracted 360 degrees from that, so that'd be rotating in the opposite direction, but still ending at the same location, we'd end up with negative 210 degrees. So 510 degrees, negative 210 degrees, and 150 degrees are all pointed in the same exact direction, and so they're all coterminal with each other. Part B asks us to draw an angle in standard position, then give the reference angle for the angle 352 degrees. Okay, so theta is 352 degrees. So going counterclockwise, starting at 0 degrees, go 90 degrees, 180, 270 degrees, back around full circle at 360 degrees. So 352 is in quadrant 4. And it's this angle here. That's my 352, that's theta. And then the reference angle, is the angle connected with vertex at the center, 0, 0, and it goes from the terminal side to the x-axis. It's always going to be a positive acute angle. And to find that reference angle, I'm going to, theta prime is my reference angle, and I'm going to subtract 360 and 352 to see what's remaining there, and we get 8 degrees. So that's our reference angle. Part C asks to draw, same instructions here, draw our angle in standard position, then give the reference angle. And our angle theta in this case is negative 672 degrees. Negative 672 degrees is going to be coterminal with negative 312 degrees. And the reason I know that is if I take 672 plus 360, a full circle, we get our negative 312. So I'm going to work with negative 312 since it's in the same, pointed in the same direction. So 0 degrees, going in the negative direction, which is clockwise, we get negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360 degrees. So negative 312 is between the negative 270 and the negative 360. The reference angle is between that terminal side and the x-axis. What I'm drawing in green here, that's theta prime. To find that, we've got to find the difference between 360 and 312. Which is 48 degrees. Number 2, we're going to be evaluating trig ratios by hand, and we're asked to find the cosine of 45 degrees. So I'm going to do this in context of our unit circle, which is the circle with center 0, 0 and has a radius of 1. 45 degrees cuts the first quadrant in half. And I'm going to drop an altitude there to make a right triangle. So this is a 45, 45, 90 special right triangle. Because it's a unit circle, we have a hypotenuse of 1. And the side lengths are root 2 over 2. Which is something we've memorized. And the cosine, we've learned in general that the x value of our coordinate on the unit circle is the cosine of any angle we're after. So the x value, or the base of this triangle, is root 2 over 2. So the cosine of 45 degrees is square root of 2 over 2. Finding the sine of 60 degrees, I'm going to set up something similar here. Unit circle, 60-degree angle in first quadrant. Drop an altitude for a right triangle. It's a 30, 60, 90 with a hypotenuse of 1. So the side opposite from 30 is 1/2. The side length opposite from 60 is the root 3 over 2. 1/2 is our x value. Root 3 over 2 is our y value, or the height. And we know that in general, within the unit circle, the y value is the sine of any angle, corresponding to it. And so the sine of 60 degrees is root 3 over 2. The tangent of 30, got your unit circle, 30-degree angle, right triangle, so it's a 30, 60, 90. Side length opposite is our y value, which is 1/2 in this case. Radius is 1. Side opposite 60 is our x value at root 3 over 2. A tangent, we know two things about, two ways to look at tangent. Tangent is sine over cosine. So in this context, it's your y value over your x value. So y is 1/2, x is root 3 over 2. If we multiply top and bottom of the fraction by 2, we end up with 1 over square root 3. We can rationalize the denominator by multiplying by square root of 3, and we end up with the tangent is the square root of 3 over 3. So that's the tangent of 30 degrees. For part D, we're asked to fill in the missing angles and missing points. We're using degrees here. This is our first quadrant, so we get 0 degrees, 30 degrees, 45, 60, and 90. This is in context of the unit circle, so this length is 1. So if I'm starting at 0, 0 and move up 1 unit, I'm going to be at 0, 1. If I move from 0, 0 directly right 1 unit, I'm at 1, 0. If I look at the 30 degree, I could draw a right triangle here. This is 30 degrees. Hypotenuse 1. The x value, the y value, which is the height, is opposite 30, so that's 1/2. The x value is opposite the 60 degrees, which is root 3 over 2. So that's what you fill in. X value, root 3 over 2. Y value, 1/2. The next one, 45. I drop an altitude here, make a right triangle. Get rid of my 30 degree marks. So in a 45, 45, 90, with this hypotenuse is the radius of the circle, still got a length of 1. Side lengths are root 2 over 2 and root 2 over 2. This is my x value, this is my y value. So I got root 2 over 2 and root 2 over 2. And lastly, for 60 degrees, I drop my altitude here, get a right triangle. This whole thing is 60 degrees. Here's my radius or hypotenuse at length 1, and side opposite 60 is your y value, your height at root 3 over 2. Side opposite 30 degrees is your x value, in this case at 1/2. So we have 1/2 root 3 over 2. And now it's all filled out the way we want it. Number 3. We're going to be working with the unit circle here. Give the coordinate on the unit circle that corresponds with 300 degrees. So I'm going to draw the unit circle here. Locate 300 degrees. So 0 degrees pointed east, 90 degrees north, 180, 270, back to 360, which is coterminal with 0 degrees. 300 degrees is between 270 and 360, closer to the 270. And our reference angle is the difference between 300 and 360, which is 60 degrees. This is 30 degrees. So we have a 30, 60, 90 triangle within a unit circle. So hypotenuse is 1. The x value is across from 30 degrees in this case at 1/2. The y value is across from 60 degrees at √3/2. Now we need to, before we go any further, we need to keep track of what quadrant we're in. We're in quadrant 4. X values are positive, y values are negative, and so we need that negative √3/2. So our coordinate that we're after is the xy value, which in this case is the 1/2, comma, negative √3/2. That's what we were asked to find. That's our answer. Part B, give the coordinate on the unit circle that corresponds with 7π/6. Okay, so on this one, we're working in radians. So we have 0 radians, we have π/2 radians, pi radians, 3π/2 radians. Now we want to find out and locate 7π/6. It's in a fraction form over 6, so I'm going to change, well, let me put one more thing here. This is 2π. So I'm going to change my pi to 6π/6. It's equivalent to pi, but now we have a common denominator, and 2π is the same thing as 12π/6. So 7π/6 is a lot closer to 6π/6 than 12π/6. In fact, here it is. So we got our 7π/6. And the difference between, okay, we have this right triangle. The reference angle is going to be 7π/6 minus 6π/6, which is π/6 in radians. To convert that to degrees, remember pi radians is 180 degrees, so 180/6 is 30 degrees. So we have a 30, 60, 90 right triangle with a hypotenuse of 1. The x value is opposite 60, which is √3/2. The y value is opposite 30 degrees, which is a length of 1/2. And we want to respect the quadrant we're in, so actually our x value is negative, and so is our y value because we're in quadrant 3. So our coordinate on the unit circle corresponding to 7π/6 is negative √3/2, comma, negative 1/2. Next, we're asked to find the sine of 315 degrees. Back to the unit circle. (315 degrees) is between 270 degrees and 360 degrees. The reference angle is the difference between 315 and 360, which is 45. So we have a 45, 45, 90 right triangle with a hypotenuse of 1, and so the x value is √2/2, and so is the y value. But because we are in quadrant 4, the y value is actually negative. And the y value represents the sine of our angle 315. So the sine of 315 degrees is negative root 2 over 2. Number 4, we're told the cosine of b is root 39 over 8, and we want to find the other 5 trig functions for b. So we know that if we're working with a right triangle, let's say this is angle B here, if we make the hypotenuse 1, that the cosine of B is the base length in this drawing. So this would be root 39 over 8. And we want to find our third side length. By using the Pythagorean theorem. I'm going to label that y, because y represents sine. So we have y squared plus the square root of 39 over 8 squared is equal to 1 squared. When I square the square root of 39 over 8, well, square root of 39 squared is 39. Square root of 8 is 64, or not the square root, but 8 squared is 64, is equal to 1. Instead of writing 1, I'm going to write 64 over 64, because I know I'm working with a denominator 64. So now subtract 39 over 64 from both sides, and you get y squared is equal to 64 minus 39, 25 over 64, and then take the square root of both sides, and you end up with y is equal to 5 over 8. And we know it's going to, well, question here is it positive or negative? And so we're going to have to assume something here. Let's assume we're in quadrant 1. Because if we were in quadrant 3, or, well, we couldn't be in quadrant 3, but if we were in quadrant 4, the cosine would be positive, but the sine would be negative. So let's assume we're in quadrant 1, so we know that the sine is positive. So the other 5 trig functions, we have cosine. Now we just found sine. So the sine of b is 5 over 8. The reciprocal of sine is the cosecant. So we know the cosecant of b is 8 over 5. I'm just going to rewrite. The cosine is root 39. So this is given to us. Cosine of b is root 39 over 8. So the reciprocal of cosine is the secant. So the secant of b is 8 over the square root of 39. Typically we rationalize the denominator, so if I multiply top and bottom by root 39, I get 8 root 39 over 39. And then the tangent is sine over cosine. Which is 5/8 over root 39 over 8. If I multiply top and bottom by 8, I get 5 over root 39, which I want to rationalize the denominator. But before I do, notice that the cotangent is the reciprocal of the tangent. So if I flip that fraction over, I get the root 39 on top where I want it over 5 for the cotangent of B. So the last piece here now is to finish the tangent. Multiply top and bottom by square root 39, and you get 5 square root 39 over 39. And we have all 6 trig functions for angle B, although we don't know what angle B is yet. And we can find it. We'd have to use our inverse trig function on our calculator. Part B. If tangent of A is 4/5, then find the other 5 trig functions for A. Again, we're going to assume we're working in quadrant 1, because tangent is positive in both quadrant 1 and quadrant 3, and depending on what quadrant in, it's going to matter for if our sine and cosine are positive or negative. So here's what we know. I'm going to draw a right triangle. Okay, and let's label this angle A. And we know that the tangent of A is equal to the sine of A over the cosine of A. And we know that ratio is going to be 4/5. So one thing we can do here is so what we do know is that the side opposite A is the sine of A, which we're not sure what that is yet, and this is the cosine of A. Well, we also, if we draw another right triangle that's similar, with angle A here, 90 degrees, and if I put, I can put 4 here and 5 here, which is not, it's not our sine and our cosine. 4 is not our sine, cosine is not A, but I know these two triangles are proportional. We have that proportion sine A over cosine A is 4 over 5. And that gives us some numbers to work with where I can find our hypotenuse in the second triangle. I'll call that H. So we have 5 squared plus 4 squared equals H squared. So that's 25 plus 16 is H squared, or 41 is H squared. So our hypotenuse is the square root of 41 in this similar triangle. So if I want to go back and find the sine A and cosine A, well, I'm going to divide all 3 of those numbers by the square root of 41. So the sine A is 4 over the square root of 41. The cosine A is 5 over the square root of 41. And I know I'm dividing by square root of 41 because my hypotenuse is 1. So when you divide the hypotenuse square root of 41 by square root of 41, you get your 1. So we're using the scale factor idea here. Because these triangles are proportional, we can just scale it back down to a triangle that's similar but has a hypotenuse of 1. So I'm going to summarize what we have here. So we know the tangent of A is 4/5. That was given. We also get that the cotangent of A is 5/4, because that's the reciprocal function of tangent. We found that the sine of A is 4 over the square root of 41, which we need to rationalize that denominator. But if we flip that over, we get the cosecant of a, which is the square root of 41 over 4. So I'm done with that one. So if I rationalize the denominator here, multiply top and bottom by square root 41, I get 4 square root 41 over 41. And we also found that the cosine of a is 5 over the square root 41, which needs to be rationalized. But before I do, flip that over, you get the secant of a, which is the square root of 41 over 5. And when I rationalize this, multiply top and bottom by square root of 41, I get 5 square root 41 over 41. And now I have all 6 trig functions of angle A. C, we're evaluating the cosecant of 180 degrees. Well, the cosecant of 180 degrees is the reciprocal, so it's 1 over the sine of 180 degrees. So if I find the sine of 180 degrees, then I got the cosecant. Now the sine is your y value on the unit circle, so I need to find 1 over y. So I'm going to draw my unit circle. (180 degrees), and we know that coordinate. It's got a radius of 1, so we're going 1 to the left of 0, 0, which is at the coordinate negative 1, 0. The y value is 0, so this is 1 over 0, but we can't divide by 0, so we say it is undefined. So the cosecant of 180 degrees is undefined because we cannot divide by 0. Part D, we're asked to evaluate the secant of negative 150 degrees. The secant of negative 150 degrees is equal to 1 over the cosine of negative 150 degrees. In terms of the unit circle, that would be 1 over the x-coordinate of that unit circle that corresponds with that angle. So locate 150, negative 150, going in the negative direction, which is clockwise. We are landing in the third quadrant. With a reference angle of 30 degrees. So we have a 30, 60, 90 right triangle. And we're after the x value only. So the x value is the length, it's a hypotenuse of 1, so the length across from 60 is root 3 over 2, but negative. And rather than deal with all this fraction, if you plug that in, let me just write the cosine. So the cosine of negative 150 is negative root 3 over 2. So the secant of negative 150, flip it over, we end up with negative 2 over root 3. Multiply top and bottom by root 3 to rationalize our denominator, and we get negative 2 root 3 over 3. Alright, next part. We have two different problems in one here, so I'm going to work on the left half first. And notice we have an isosceles triangle. The base angles are the same, so length AB, which is 13, matches length BC, which is also 13. And if I drop an altitude here, I create a right triangle. With each right triangle has base length 12. And we're focused in on angle A, so I'm just going to look at the right triangle I'm outlining with my highlighter. Before I go any further, I'm going to solve for the height using Pythagorean theorem. Let's call that our y value. So we have 12 squared plus y squared is equal to 13 squared. That's 144 plus y squared is 169. So y squared is 169 minus 144, 25. So y is 5. So that's a height of 5 there. And I'm going to now draw a similar triangle. Right triangle, same angle A here, but with a hypotenuse of 1. So I'm going to scale it back. And the way I'm going to scale it back is I'm going to divide the 13, the 12, and the 5 all by 13. Because 13 divided by 13 is my 1. So 5 over 13 is opposite A, and 12 over 13 is the base length. And now I know from this that the sine of A is 5 over 13. The cosine of A is 12 over 13. Reciprocal of sine is the cosecant. Was I asked to find that? No. Just the tangent. Okay, so now for the tangent of A is sine over cosine. So 5 over 13 over 12 over 13. Multiply top and bottom of your fraction by 13, you get 5 over 12. Alright, so that's part 1. Part 2. If tangent of A is 1/3, find the perimeter and the area of ABC. Okay. So I'm going to drop my altitude again. Focused on angle A. So I got this right triangle. Base length is 15. I'm going to highlight the triangle we're going to first work with. Now here's what we understand. If we scale this triangle down and draw one that's similar to it, right triangle with a hypotenuse of 1, same angle A, they're similar. We know this is the sine of A, This is the cosine of A. Okay. And we know that the tangent of A is 1/3. So the ratio of side lengths, the sine A over cosine A, is 1/3. So I'm going to draw a third right triangle, a little bit bigger. Same angle A. This side 1, this side 3. Okay. So all three of these triangles that I've drawn are similar to each other by angle. They all have angle A, and they all have a 90-degree angle. Well, now let's compare the triangle we're interested in with this triangle with side lengths 3 and 1. We can see how to go from 3 to 15, scale it up by a multiple of 5. So multiply 1 by 5 to get the height, and you know that, okay, our height's going to be 5. Alright, so now back to the triangle we're interested in. We need to find the perimeter and area. We can find the area already because the area is the base times the height. So let's do that. 1/2 base, which is 30 for the full triangle, times the height, which we just found is 5. So that's 15 times 5, because 1/2 of 30 is 15. And 15 times 5 is 75, and we're talking about squared units. Now for the perimeter, we're going to have to find the hypotenuse of this highlighted triangle using Pythagorean theorem. So let's call length r here. So we have 15 squared plus 5 squared is equal to r squared. 15 squared is 225. 5 squared is 250. Sorry, is 225, and is equal to r squared. When you add 225 and 25, you get 250 is equal to r squared. And then you can take the square root. So r is the square root of 250. We can simplify that a little bit. 250 is 25 times 10. And we can take the square root of 25, so we get 5 root 10. So we got 5 root 10. It's isosceles, so this is 5 root 10 and 30. So the perimeter, you add all three lengths, 30 plus 5 root 10 plus another 5 root 10, and you end up with 30 plus 10 root 10. And we found our area and our perimeter. Number 5, we are working with radians, and we're first asked to draw 8 pi over 7 radians in standard position. So what we know is that 0 radians, 0 degrees, same spot. 90 degrees is pi over 2 radians. Which is true, but actually we don't even need to do that. We're just going to put 0 and pi radians, and then back to 2 pi radians. Because pi radians, always remember, pi radians is equal to 180 degrees. So if we're drawing 8 pi over 7, let's change pi into something over 7. So if I want, right now it's pi over 1, so I'm going to multiply top and bottom by 7. So pi is the same as 7 pi over 7. 2 pi is the same as 14 pi over 7. 8 is past 7, but closer to 7 than it is to 14. So 8 pi over 7 is in quadrant 3. And we have our sketch. For part B, we have, again, we're working in radians. Get 0 radians, we have pi radians, and back to 2 pi radians. And here we're working with 4 radians. Remember, pi is roughly 3.14. So 2 pi, if we double that, would be roughly 6.28. So 4 radians is bigger than 3.14, so bigger than pi, but closer to pi than the 2 pi, so we're going to be in quadrant 3. So this is roughly 4 radians. Alright, this is 3.14. This is 6.28. C says find two angles in radians, one positive, one negative, that are coterminal with 3 pi over 10. When we were working with degrees, we would add or subtract 360 degrees because 360 degrees is a full circle. Same idea here, but in radians, 2 pi is a full circle. So I'm going to add and subtract 2 pi. So 3 pi over 10 plus 2 pi. Well, let's get a common denominator because we're working with fractions. That's 3 pi over 10 plus 20 pi over 10, because I took the 2 pi over 1, multiplied top and bottom by 10, and then when we add, we get 23 pi over 10. That is a positive coterminal angle with 3 pi over 10. And then subtract, and we get 3 pi over 10 minus 20 pi over 10, which is our 2 pi, and that is negative 17 pi over 10. For part D, we want to convert 235 degrees to radians. So we can set up a proportion, and I'm gonna, doesn't matter, but we're gonna, I'll do radians to degrees. And so we have 235 radians. We're not sorry, we have 235 degrees, don't we? We want to find radians. So we don't know our radians. So I'm going to put x for radians, and 235 degrees is equal to, now I'm going to, in this next fraction, I'm going to put something I understand here. So I know that pi radians is 180 degrees. So here's a proportion. The right side is equal to 1 because pi is the same as 180 degrees, and then the left side is equal to 1 because we're looking for the number of radians that is the same as 235. So this proportion works out here, and we can use it to solve for radians here. So I'm going to cross multiply and get 180 x is equal to 235 pi, and then divide by 180 and get x is 235 pi over 180, and the rest is working on this and just trying to reduce our fraction. So we're thinking of a number that goes into both 235 and 180. 5 goes into both. 235 divided by 5 is 47. And 180 divided by 5 is 36. 47 is prime, so that is as good as we can get. That's equal to 235 degrees. We're going to convert now negative 330 degrees to radians. Again, I'll set up my fraction radians over degrees. Okay, I don't know my radians, so that's x, but I know it's equal to negative 330 degrees. So that fraction is equal to 1. Also, I know that pi radians over 180 degrees is also equal to 1. And so now I have my proportions that I can use to cross multiply. So 180x is equal to negative 330 pi divide by 180, and we get x is equal to negative 330 pi over 180. Could divide top and bottom by 10 and get negative 33 pi over 18. 33 is 3 times 11. 18 is 3 times 6, so we divide by 3 again. You get negative 11 pi over 6. 11's prime, so we're done reducing. Part F, we're converting radians to degrees. We can use the same method we used in the last, where we set up a proportion, but I'm going to use the fact that pi is 180 degrees, and I'm just going to substitute that into our problem here. So if I have 2 pi over 3, that's the same thing as 2 times 180 degrees over 3. Well, 180 divided by 3 is 60, so this is 2 times 60 degrees, which is 120 degrees. Again, we're going to convert radians to degrees. I'm going to use the same method. We got negative 3 pi over 5, which is equal to negative 3 times 180 degrees over 5. 180 divided by 5 is 36. So this is negative 3 times 36 degrees. And 36 times 3 is 108 degrees. True or false? 2.3 radians is in quadrant 3. Well, starting at 0, moving counterclockwise, half a circle is pi radians, which is 3.14. So 2.3 radians would end in quadrant 2 and not quadrant 3, so that's false. Number 6, we're evaluating some trig by hand. We want to find the sine of negative pi over 2. Here's 0 radians, negative pi over 2 radians, negative pi radians when we're moving in the negative clockwise direction. If I sketch the unit circle on here, got a radius of 1, the coordinate at negative pi over 2, because we're just dropping down 1 from 0, 0, is negative 1, 0. Actually, 0, negative 1. And we want the sine the y value, so sine of negative pi over 2 is the y value on the unit circle, which our y value is negative 1. We want the cosecant of pi over 2, here's 0, here's pi over 2 at 90 degrees, pi at 180 degrees. The coordinate on the unit circle corresponding to pi over 2 is 0, 1. Cosecant is the reciprocal of sine, so the sine of pi over 2 is the y value, which is 1. So the cosecant of pi over 2 is the reciprocal of 1. Well, 1 is 1 over 1, and if you flip that fraction over, you still get 1 over 1, so it's still going to be 1. Part C, we're asked to evaluate the 6 trig functions for theta equals negative 17 pi over 6. So first of all, realize that this is larger than 2 pi, or negative 2 pi. Negative 2 pi is equal to, or negative 2 pi over 1. If I multiply top and bottom by 6, I get negative 12 pi over 6. So if in terms of degrees, if I were to change this to degrees, this would be more than negative 360, or negative 360. So I'm going to find a coterminal angle by adding pi over 2 to this, which is 12 pi over 6. And I end up with negative 5 pi over 6. So I'm going to use that to help me get my reference angle. So negative 5 pi over 6. So in the negative direction, this is 0 going to negative pi, which if I put it over 6 would be negative 6 pi over 6. So negative 5 pi over 6 is in the third quadrant. Got your right triangle here. And the difference between 5 pi over 6 and pi over 6, 6 pi over 6 is pi over 6. So my reference angle is pi over 6. It's easier to think of this in terms of degrees, so that's 180 degrees over 6, which is 30 degrees. So we're working with a 30-degree angle. So we have a 30, 60, 90. Hypotenuse is 1. The x value is across from 60, so it's negative root 3 over 2. The y value is across from 30, so the y value is negative 1/2. So the coordinate we're working with, the x and y value, is negative root 3 over 2 and negative 1/2. So from that we can get our sine and cosine. The sine, we're working with 17 pi or negative 17 pi over 6. So the sine of negative 17 pi over 6 is our y value at negative 1/2. The cosine of negative 17 pi over 6, let me fix that 17, doesn't look good. Is our x value at negative root 3 over 2. Our cosecant is the reciprocal of sine of negative 17 pi over 6 is negative 2. If you flip over negative 1/2, you get negative 2. Our secant of negative 17 pi over 6 is the reciprocal of cosine, which is negative 2 over root 3. Rationalize the denominator, multiply top and bottom by root 3, and you get negative 2 root 3 over 3. And then the tangent of negative 17 pi over 6 is going to be sine over cosine, so negative 1/2 divided by negative root 3 over 2. If I multiply top and bottom by negative 2, I get positive 1 over root 3, which if I multiply top and bottom by root 3, I get root 3 over 3. And the cotangent of negative 17 pi over 6 is the reciprocal of tangent. Instead of grabbing root 3 over 3, I'm going to grab 1 over root 3, because if I take the reciprocal of that one, I'm going to already be rationalized in my denominator, and so when I flip that one over, I get square root of 3. So again, if you didn't catch that, I took the 1 over root 3 reciprocal to get this one. Alright, D, we're doing the same thing for 15 pi over 4. Uh, 15 pi over 4 is going to be more than 2 pi. So I'm going to subtract 2 pi from that. Which is 15 pi over 4 minus 8 pi over 4. 15 minus 8 is 7 pi over 4. So that's what I want to work with. Get our unit circle. 0, pi over 2, pi, 3 pi over 2, 2 pi. But to put this in terms of a denominator 4, this is 8 pi over 4. 2 pi is equal to that. Pi is equal to 4 pi over 4. So 7 pi over 4 is closer to 8 pi over 4, so we're going to be past pi, but not quite 2 pi. We're going to be right around here, so 7 pi over 4. So we have our right triangle with our angle. Our reference angle is going to be the difference between 8 pi over 4 and 7 pi over 4, which is pi over 4. Remember, pi is 180 degrees, and 180 divided by 4 is 45 degrees. So we're working with a 45, 45, 90 right triangle. Doesn't look like it's drawn to scale, but that's what we have. The hypotenuse is 1 because it's in the unit circle. The x value is root 2 over 2, positive. The y value is negative root 2 over 2. So I'm going to put that up here, change colors. We have our coordinate, xy, which is positive root 2 over 2, comma, negative root 2 over 2. So from that coordinate we can get everything we need. The sine of 15 pi over 4 is the y coordinate, which is negative root 2 over 2. The cosine of 15 pi over 4 is the x coordinate, which is positive root 2 over 2. The tangent of 15 pi over 4 is the sine over the cosine, which is negative 1. And then let's get the reciprocal functions. The cosecant of 15 pi over 4 is the reciprocal of sine, which is negative 2 over root 2. Multiply top and bottom by root 2, you get negative 2 root 2 over 2. We can reduce that to negative root 2. Reciprocal of cosine is the secant, which is 2 over root 2, and the same work as above, so we're going to end up with positive root 2. And the reciprocal of tangent is the cotangent, reciprocal of negative 1 is negative 1. And we have our 6 trig ratios for 15 pi over 4 radians. Alright, same thing for negative 4 pi over 3. Negative 4 pi over 3, well, let's see, we have 0 going in the negative direction. This is negative pi. But if we make the denominator 3, this would be negative 3 pi over 3. And then back around to negative 2 pi, which is negative 6 pi over 3. 4 is closer to 3 than to 6, so we are moving around. We're past 3, so we're in quadrant 2. At negative 4 pi over 3. We have a right triangle here, and the reference angle is the difference between 4 pi over 3 and 3 pi over 3. Which is pi over 3. Pi is 180 degrees, so this is 180 degrees over 3, which is 60 degrees. So this is a 30, 60, 90. Hypotenuse is 1. The x value is across from 30 in the negative direction, so negative 1/2. The y value is in the positive direction across from 60, so that's root 3 over 2. So we have the x and y value. On the unit circle, the x value is negative 1/2. The y value is positive root 3 over 2. So the sine of negative 4 pi over 3 is our y value, root 3 over 2. The cosine of negative 4 pi over 3 is our x value, which is negative 1/2. The tangent of negative 4 pi over 3 is root 3 over 2, the sine, over the cosine. Multiply top and bottom by 2 and you end up with negative root 3. The reciprocal of sine is the cosecant, and that's going to be 2 over root 3, which is 2 root 3 over 3. Reciprocal of cosine is the secant, which is negative 2. Reciprocal of tangent is the cotangent, which is negative 1 over root 3, which is negative root 3 over 3. And we have our 6 trig ratios for the radian measure of negative 4 pi over 3. Alright, the last one we're asked to evaluate the 6 trig functions for theta equals negative 5 pi over 6. So here's my unit circle, 0 radians, negative pi radians, which is the same thing as negative 6 pi over 6 radians. And so 5 is closer to 6 than it is to 0, and so negative 5 pi over 6 is going to be in the third quadrant. And the difference between negative 5 pi over 6 and 6 pi over 6 is pi over 6. Remember, pi is 180 degrees, so we get 30 degrees. So it's our 30, 60, 90. Radius of 1, the x value is going to be negative root 3 over 2. The y value is going to be negative 1/2. So we have x, y as negative root 3 over 2, comma, negative 1/2. Our x values are cosine. Negative 5 pi over 6 is equal to negative root 3 over 2. Our sine of negative 5 pi over 6 is the y value, which is negative 1/2. The inverse of cosine is secant. So we flip over, not the inverse, but the reciprocal function. So we flip over the negative root 3 over 2 and get negative 2 over root 3. Multiply top and bottom by root 3 and you get negative 2 root 3 over 3. The reciprocal of sine is the cosecant. And the reciprocal of negative 1/2 is negative 2. The tangent of negative 5 pi over 6 is sine over cosine, so negative 1/2 over negative root 3 over 2. Multiply top and bottom by negative 2 and you get 1 over root 3. Multiply top and bottom by root 3 and you get root 3 over 3. And then the inverse of, or sorry, not the inverse, but the reciprocal of tangent is the cotangent of negative 5 pi over 6. And I'm going to choose to take the reciprocal of 1 over root 3 to get root 3. And there are 6 trig ratios for theta equals negative 5 pi over 6.